very well indeed.
Just switched on the airco a little bit.
Mm.
It needs to cool down here.
Yeah. Well, I'm glad
Oh,
you've got one. Yeah. As I understand, a lot of folks in Europe don't have an air conditioning unit. They just usually
here
don't need it.
in the south of France, usually yes.
Oh, yeah, that's true.
Uh,
Okay.
Units which can heat and cool.
Hmm.
So, but most of the time we use them to heat in the winter.
Mm-hmm.
And I try not to use it to cool in the summer, but to keep the electricity bill down.
Yeah.
But sometimes, yeah, you better cool down a little bit because otherwise it's not gonna work out.
No.
Oh, it's so hot for the moment. So
Yeah. Well, we finally did get a little bit of a break yesterday. Got some rain, so it
okay,
it cooled down. Uh, Alexa, what is 90 degrees Fahrenheit in Celsius?
90 degrees Fahrenheit is about 32.2 degrees Celsius.
Yeah, so get down to 32 degrees.
and what was it before?
Before it was 100 Fahrenheit, which is about
Should be about
uh,
40, more or less. It's not completely linear, but
yeah. Is it 5/9 is the ratio? Something around that. So, but yeah, no, I think it wouldn't be quite 40. I think it would be more like 35. Yeah. I think as you go up 9 degrees Fahrenheit, you go up 5 degrees Celsius. So
yeah.
so actually it would
So
be more like 37. Yeah.
37,
Yeah.
38.
Yeah.
That's
Anyway.
that's more than enough. So in Texas you do have airco, but you don't have heaters.
We do have both.
Okay.
Yeah. So we've got a couple of big compressors with fans outside yeah, that most of the time they're used for air conditioning, but yeah, we can flip it to heat, and that's usually like we've got natural gas coming to the house, so we'll use natural gas in order um, to start a little fire and blow air past it, heat
Yeah.
some elements. So, yep, it's uh, we have to control it in both directions.
If you could just average it out over the year, then it
Yeah,
would be perfect.
that'd be great. Yeah, yeah. If we had a little heat storage unit, and
Yeah.
so yeah, we just store up all this heat and keep it nice and cool in the house, and then we slowly release it in the winter.
Principle is more easy than historical modeling.
Yeah, exactly.
So why didn't take?
I mean, goodness, do we have to
Good.
solve all problems for people? Come on.
Michael, historical modeling.
Mm-hmm.
Yeah, I just saw that you have the replicator image.
Yes, I do.
That's very good news.
Yep.
But
Currently
so
completely undocumented, but it's out there at least.
that's still okay. Postman, very nice. I managed to get connection to the database. But let me see. I'm trying to start it up again here. Okay. But then
Yeah, go ahead and share so we can see what you're
I
what you're
will
doing.
share it. And must be this one, I think. Yeah, that's. Can you see it like that?
Yes.
So the first one is just copy of the code you
Mm-hmm.
showed us. So sending request, and here is the reply.
Mm-hmm.
It's very nice to play with it because then you start understanding the structure and why and the projections and so on. And I say, okay, now I want to see all the courses by Michael. And then I got back to, where is it? Yeah, it was, I think, in the weekend that I played with it.
Uh-huh.
Yeah. And then I got back to chapter 3 of the book, page 81, querying the model, page 82, jumping the levels, joining matches. And then I got completely confused. For example, 83. On 83, you have the cards containing product P, where you have the possibility, so the order line dot price dot product. So exactly what we could do in the C# link.
Yes.
And then I started thinking, here, if I go back here, we can only have one step in the expression.
You can actually have another step after after the type declaration. So prior colon improving you course instructor arrow, and then you can do the next step from there. So yes, you can have multiple steps.
So we could something like this.
Yes.
Going to my prior.
Yes.
No,
Even So
the next prior.
Yeah.
Of new type, and that equal to instructor.
Right. Yes. So in that particular pattern, it doesn't make much sense, but yeah, that is that is how you would do that in here.
Okay.
The problem that you're running into is actually not related to that, though.
No, but I started thinking how does it work, and if I start thinking, that's not good for me. Because my next idea was let's find out. Michael said that 3.1 is released, and so the client side is also adapted. So now I can make an expression in JavaScript, j.fact and j.query. So I can write the query as a j.query in JavaScript, and then I should be able to intercept, if I do it in the client environment, like, for example, shared list, then I could intercept the communication between the client and the server, and then I have my specification language.
Yeah. Unfortunately, 3.1 does not use the specification language from the client. It just publishes it. So the next release, which will probably be 3.2, will actually produce the specification language instead of the linear pipeline.
So the communication between client and server is still the old the N and the S and the F.
Yes, exactly.
Okay.
Yep. I wanted to get the specification language out there primarily to support Jinaga.net, so that we could start making Jinaga.net talk specification language. But then when I saw how useful it was just as a human, I said, okay, I need to be able to run specifications from the read endpoint. But these so far this is half of the solution. It's just the just creating the endpoints, and the other half is the solution of consuming those endpoints is still upcoming.
Okay, so my idea would not have worked. Then let's see here if I...
The problem that is happening right there is you're defining a fact called top instructor. Top
instructor, yeah.
And the only thing that is present in that fact is a field called value. So it has no predecessors. And so that is going to explicitly match a fact of that type, improving your course instructor, with just that field. It's not going to match all facts that have a field equal to that value. It's computing that very specific identity.
Yeah, because it should have itself as a predecessor. If you look to this one, that's just a printout
Yep.
of what you showed. So we have the course, the instructor over here, the second one.
Mm-hmm.
So it points to itself and it points to the course.
Right, exactly. Yep, that is
So
the mutable property pattern.
yeah, but then because it points to a course, but then that's just what I want to know.
Yeah. So if you wanted to be able to support this kind of query, which actually is a very good kind of query to support, you would have to modify the model to do so. So since an Improving You course instructor is a mutable property of a course, in order to create one in the first place, you need to know which course it is.
Yeah.
So so what you're really trying to get out of the model is to say, I want a fact that represents the instructor Michael Perry within this company. So, and the model doesn't work this way, so this query still won't work right now. But yeah, if you had that kind of fact, we'll just call it Improving You instructor. So it's not actually related to a course yet. Improving You instructor, value Michael Perry, and company is equal to that company that's defined right there, the improving company. So if you had one of those, then that would mean that every time Michael Perry teaches a course at Improving, you use this particular fact, this exact same instance. And the fact can't know about the course yet because you have to be able to express that fact as a parameter first, and then find the courses. So the courses have to be successors in some way.
Yeah. So could we do like we did before in DWS, where we had a fact, we had another fact, two facts here, and then we assigned them.
Yes.
So I have an
Yes,
instructor,
exactly.
I have a course, and then I assigned the instructor to the course.
Yes. Yes, exactly. That is not the mutable property pattern, but one that's very related to it. I think I called that the assignment pattern. Entity reference. Chapter 8.
No, 8.
Yeah. So that one's actually on page 265, the entity reference pattern.
265.
Yeah, 265.
Okay. That's order line to product. Okay.
Yeah. So in that example, since you're using product as an entity, you can have a reference directly to a product, and then you can use that product fact as a parameter in a query, because you can now create that product fact without knowing any of the orders or the order lines. But now that you can create that product fact, you can create a specification that defines all of the orders having order lines that are successors of that product.
Okay.
So yeah, what you're trying to do here with this specification is to find all courses with a course instructor that is a successor of that instructor. But the model is not constructed that way, so that query would not work.
So if I would like to do that, I would have to load all the courses and all the instructors, and then do a local link query on that collection.
Yeah. So the way that you would do that right now is I would say project that into some JSON that then you can load into Elasticsearch. Perform the search with Elasticsearch. You find all of the course IDs, and now you can load those core facts. So yeah, that's the way to get a search out of a historical model if the model wasn't designed to support that search. And that way you could do even more interesting searches. So maybe there's some property of the instructor, is the instructor an approver or an external instructor, or maybe I'm looking for the instructor's job title or something. And so these are things that you might want to query by, but they are just properties of a thing. They're not a thing itself. So I'm not looking for all the courses by that particular instructor. I'm just looking for the courses by principal consultants, for example. So Elasticsearch is really good at that kind of property-based query. I mean, you can even do greater than, less than, between, ands, ors, nots, all that kind of stuff. But Jinaga is set up just for queries from a specific known fact.
Michael, with these queries, I think often you will have just, let's say, 50 results, and you want to have, for example, the best paid instructor.
Yeah,
and the model
good,
is not really adapted for it.
Right.
In that case, wouldn't it be easier that you just get it into a collection and do a link query on that?
Yeah.
Directly on the collection, which doesn't go to the Jinaga database?
I would say yes, that would be easier than just going to the Jinaga database. I would say then one step further from that is, rather than that being an in-memory collection, you can go ahead and project that into a persisted search index like Elasticsearch. And that way you can perform that search very quickly without having to load things into memory before you do that. And take advantage of any of the other features of Elasticsearch, like matching based on somebody's name. So you should be able to search for Mike and find Michael. Elasticsearch does that, but yeah, your in-memory search, you would have to build those kind of capabilities, and then it would just be transient for that period of time that you have it in memory. So yeah, I like the idea of using a historical model for OLTP kind of things, the transaction processing things, and then you project into some other store in order to perform search and reporting, aggregation, star schema, dashboard, all that stuff. Those are done outside of the historical model based on a projection.
Good. So I will still be playing a little bit with this one.
Yeah. Yeah. Now,
The
if you really did want to support that kind of a specification, which honestly I think it would be a good thing to do, then you would have to change the model. And this is precisely where you would want to introduce one of the strategies that we talked about probably last year of transforming one model to another. So if you can project from the existing model into a new model without introducing any new information or destroying any information, then you've got a projection that runs anywhere and produces a good model. So yeah, you can start that projection running on a replicator. It can transform from the model that it's receiving into the new model, and then that now is just part of the substrate, and now you can consume the new one as well.
Yeah. Okay. And in fact, the new model is automatically updated by the old model every time a fact comes in.
Yeah, exactly.
Yeah.
That's the cool thing about these replicators.
Mm-hmm. So let's find out about the replicators.
Yeah.
Let's stop this stream.
All right. So what I have working right now, we've got Docker desktop running. no images currently running, and I want to be able to create some facts and some specifications inside of Postman. So I've got Postman ready to go over here with an empty collection. And so I'm going to start by creating a brand new Docker container that is a replicator. So we'll do a Docker run, and then I want to give this a name. So I'll call this the blog replicator, so that I can start building my blog model. Expose port 8080 as port 8080, and then I want to run Jinaga-replicator. All right, and so now we can see that it has created a Postgres database. So the database is inside of the replicator container, and then it has also in parallel started up a Jinaga server. So that is listening at HTTP 8080. And so we've got a replicator running, and if we take a look at our containers, sometimes I need to flip back and forth to refresh, but yeah, this thing is, there we go. Yeah, definitely running a new container. And so now I should be able to start putting facts into that replicator. So let's create a new request, and this is going to be create blog post. So in order to create a fact inside of the replicator, I want to post to http/localhost, and it's running on 8080. It's exposed via 8080, and then I want to do a Jinaga/write. So now I can write facts into that replicator, and the body is going to be the set of facts that I want to write. So let's say this is going to be a raw text body, and let's start with the site. That's going to be a blog.site. And so we need to be able to distinguish this site from any other site, so we need to give it some field that can be used as that differentiator. So we'll call it domain, michaelperry.net. And then when we send it, that is going to create a fact inside of our replicator. So it gives me back a 200 OK and just an empty response. So maybe I'll change this to a 201 created, because that's really what just happened there, is it created some information. And then now that we have that create a blog, well, we've created the blog site, but now we need to create the blog post. So let's let the post be a blog.post. And so that's going to be within the site. And then to distinguish this from other posts in that same site, I'll have created at, which will be a date. So 2022, August 11, and then the time is 1340 Zulu, UTC. Okay, so send that in, and now we've got the blog post. So now we need to be able to list all the blog posts on a particular site. So I'm going to create another request, and this is going to be list blog posts. And we do this by posting a specification to not Jinaga.write, but Jinaga-read /read. So this also has a body, and that body is raw text. And we're going to start with the blog site. But now we want to do the specification. So let's let, if we've got a site being a blog site, well, let's let it match some tuples. So this tuple will just have a member called post, which is a blog post, such that post arrow site being a blog site is equal to that site. So when I send that in, then we've got a type mismatch. Because I need to capitalize the site. So that type needs to match that type. Okay. There we go. So, yep. So now I'm getting back a collection of tuples, and these tuples just have one element, the post, and I'm seeing all of the fields of that post. I'm not seeing the predecessors, because that would be a huge tree. If you really want the predecessors, include them in the tuple. But what I want to do is project these tuples into a specific JSON value. So rather than have post with created at, let's just do created at and set that equal to post.created at. And so now that should collapse at one level, and I just see created at coming out. And that will let me add other properties to the post so that I can see everything that's going on and project those. So let's flip back here and let's add a property. Let's add a blog title, or a title for the post. So let's let the title being a blog post title. That's the pattern that I like to use for adding a property to a thing, is use that thing's type and then extend it with the name of the property. And so that's going to be for this particular post. The value of that property is going to be Introduction to Jinaga Replicator. And then since this is the immutable property pattern, I'm going to give it a prior array that is empty to start with. So when we have new versions of this value, when we replace one value with another value, then we can put the previous one inside of the prior array. But for right now, that's going to give us a title for that post. So hit send, and now that is in the replicator. So that means out here I should be able to query for that title. Right now it's just giving me the created at. I should be able to add the title to the projection. So that's going to give me back another tuple, just having title being a blog post title, such that the square brackets are the such that. And so inside of here you've got your conditions, like the title arrow post being a blog.post is equal to post. So when we send that in, unknown title must appear on the left side of the path. Oh, I mistyped it. There we go. Nice helpful error messages. I strive to have helpful error messages. Okay, so now I'm getting the matching title facts, but as you can see here, it's returning it as an array. No specification can return a single fact. It always has to return a set. So let's make that more explicit by calling that titles. And then furthermore, let's take this title.value and let that just be the value of that we project. So title.value. There we go. So now I'm getting back an array of posts. So for each post I can see when it was created, and I can see the current titles. So let's go ahead and change those titles. So so here I've got a blog post title. Let's I'll let title 2 be another blog post title for the same post, but now let's change the value to Jinaga Replicator Advanced. And here, prior is going to be an array containing the original title. So now this is going to replace that one with a new property, a new value for that property. So send that in. That creates that that new successor fact. And so now if I run this query, I get back both of them, because they're both matches to this condition. They are both blog post titles within this post. But I really only want the most recent one, so I want the one where there does not exist a next blog post title, such that next prior, which is in this case an array of blog post title, but we don't need to explicitly say that it's an array. It's just there is no successor, or there's no predecessor in that role, where next prior is equal to the title. So that should exclude the ones that have been replaced. So it should exclude Introduction to Jinaga Replicator and just give me back Jinaga Replicator Advanced.
Yep.
Yep. So there we go. This is a model that I can export from Postman, share with somebody else, and say, hey, you go ahead and run your own replicator. And so I'm going to go ahead and stop the replicator so that we can see, okay, it's got to hang up. There we go. So I just say run that command to create your own replicator, and then use this Postman collection in order to populate some facts in that replicator. And now you can go back in here and you can stop it and restart it, and those facts are saved. There is a Postgres database inside of that replicator container, and so Docker has already mounted a volume to capture all of that data, and so when you start it and stop it, it's going to remount that same volume and give you back that same data. And then with that information, somebody should be able to populate their replicator and then use this to write some JavaScript code and create a React component that displays all of the blogs, the blog posts for a blog. I'll create another Postman collection, give that to somebody else, and say, hey, I want you to do the comments, and so they create the comment component. I give another one to somebody else, and I say, hey, I want you to call this API in order to post to Twitter anytime I publish something on the blog. And so they just subscribe to this specification and call the Twitter API to send out that link. So so then we just compose up an application out of these parts and get that deployed.
Good. And you registered it this time?
Yes, this time it looks like it recorded everything.
Okay. Oh, otherwise you have to go back in time. I don't remember the name of that movie, but
yeah, there have been several good ones. Yeah, so back here.
Back to the Future.
Yeah. Yes. Yeah, Back to the Future is definitely a good one. one that takes a very interesting approach to time travel is Tenet. So you can only travel backward in time at the same rate as you would travel forward in time. So you reach a point, and then you flip around and you start going backwards. So it's pretty cool how they weave that into a story, and it's got a lot of rewatch value.
Called Tenet?
Yeah, Tenet, Tenet. So the title is also a palindrome, which shows you that time flows forward and backward at the same rate.
Mm-hmm.
Very cool one.
Good. One of the things I think would be interesting for the ones who are interested in the code itself is to extend. One time we made a diagram.
Yes.
JavaScript, C# server client. A similar diagram, but much more. Where in the code do we find that? Where in the code do we find that? It becomes easier to, especially around the interfaces.
Yeah, I'm looking at Jinaga.com, and I don't think we published that on Jinaga.com. That might be in the...
yeah, it's published somewhere. No, it's on GitHub somewhere. It's on GitHub. GitHub.com/Jinaga, no? Let's see, and then we take Jinaga. It's not on Jinaga.net somewhere. Jinaga.net. Yeah. So if you go to github.com/Jinaga/Jinaga.net, and there in the README, if you scroll down, there you have it.
Okay.
Anyway, now the...
Okay. Yeah, there it is.
Yeah.
Yep.
So anyway, the interface has been changed also. We have now this read, we have write.
Yeah, so we need to add some arrows there for reading, writing. The polling, we can be a little bit more specific there. That is, that's going to be feeds, and then this box over here, we can call that the
I don't see the
replicator. Oh, yeah, sorry. The big box to the right. It currently says Jinaga.js server and Jinaga.net server. We could call that replicator. Yeah, because that has... Yeah, that is everything there. Yeah, and then the interesting part there about you've got your authorization rules and your distribution rules inside the replicator. That is still going to be very soon possible with the replicator image. When you use it as a base image, you'll be able to supply authorization rules and distribution rules in JavaScript in this case, and then it will run those rules inside of the replicator.
Okay, so that will be a file with specifications that you load in.
Yes, so that'll be just like right now. If you were to run, let me go to an example. I want to pull up the improving you example. Yeah, it looks like this is C Control R, improving you course library. So let me do a share here so you can see that as well. Okay, so in the Improving You application, we've got a in source shared, because this is code that's running on the server as well as the client. So within our model, there are these little functions that that authorize different facts. So we can authorize a catalog. So so like the yeah, that one's actually not all that interesting. Let's go with the course. That's going to be a lot more interesting. So, oh goodness, that's not very interesting at all. Okay, it's unfortunately wide open on the courses. But I know ideas are wide open. Let's see about session. Okay, I'm going to need to work on my authorization rules. Okay. Well, the yeah. So we'll go back to this one. So so here we can say that who can create a director. So we do a director.company, go back up to the company predecessor, and then go down to all the directors of that company. And so then up to that director user. So if you are already a director of the company, then you can allocate another director for the company. So you can invite somebody else in. Right here, the company's creator can introduce a new director. So, and then we can revoke the creator. We can remove directors. So who can do that? The company creator or other directors. So all of these authorization rules tell you for a particular fact which users are permitted to create those facts. And so with Jinaga Server, what you do is you take this this function or this set of functions, and when you say I want to create a Jinaga server, you say here's my fact authorization function, and it just says use all of those authorization functions and create a set of authorization rules from them.
Okay.
So that code, you should be able to write that code in JavaScript and then use the replicator as a base image, and then just overwrite a file that's already in that base image with your code, and then it'll start running the authorization rules. And so that's how you would get that box into the replicator.
Yeah. So the authorization rules are per server. They will not be replicated to another replicator.
Correct, yes. Yeah, and that's going to let you do some really cool things with replicators. Like for example, you should be able to create some authorization rules that represent just the facts that are at the boundary, the way that you want to interact with a partner, and then create a replicator that only authorizes those externally visible facts, and doesn't authorize any internal facts. And so now within your organization, you're doing all sorts of collaboration, but then the only things that that edge replicator will accept are the external facts. And then you expose that to a partner. They might be running Jinaga internally, and then they just set up a replicator to replicator connection. And so now they are pulling in all the facts that you've authorized. And when they send you facts, you're authorizing those from their side and making sure that they're just the facts that they're allowed to send you. So you can distribute different authorization rules yourself to different parts of your network in order to build a structure that has those entry points.
Yeah, but that might be not so easy to maintain.
Yeah, there definitely is going to have to be some practice around it. But one of the, and so that's how you would do that with the replicator image, that we're currently building. But ultimately, I do see a software as a service where you get to express your authorization rules to that software as a service and say, okay, I want these to be the authorization rules for the edge. I want those for internal, and then it sets up that structure for you. So that'll be a service that an immutable organization can pay for to have all of their replicators hosted and set up for them.
Yeah, so they don't need to start their own servers.
Yep.
Indeed.
Yeah, so that is a sneak peek at the this business model as well. So we're ultimately, all the money for supporting this is going to come from is that software as a service offering.
Yeah. There's still a lot of work to be done.
Yep.
I think what would also be nice on top of that is a lot of model queries. Because for the moment there are quite a few models now. There is improving you model, there is the airline model, there is the DWS model, but a very limited number of real life queries for the moment.
Yeah.
And I think it would be nice. That's something with DWS. All the queries, I can just keep them. And that, I think, for people to learn about it, and perhaps the query like it is in C#, the query like it would be in JavaScript, and the specification language. Then you can immediately compare it.
Yeah, have a bit of a Rosetta Stone there. Yeah, and then you could just run your own replicator, put those facts in, run the specification, see the facts. Okay, now let's run the C# code. Oh, and now it's rendering those in Razor. Oh, let's run the JavaScript code. Okay, it's rendering those using React. And okay, this makes that would help it to really make sense to people, and they wouldn't have to do an awful lot to get those working. It's mostly copy and paste. Paste this command line, paste these into Postman.
Yeah, but it's especially the idea from, like I had, how to get all the courses made by Michael. It's not immediate possible because, but if you have a number of examples, every time I run into such a stupid thing, I can just document it.
Yeah.
That would avoid others to have the same problem.
Yes, indeed. Yep. So my next task is going to be to do some documentation
about the replicator.
Yes. Yeah. So all that documentation that you were just talking about with those examples. The reference of the specification language. So yeah, you should be able to go to a page on Jinaga.com and now completely understand what a replicator is, how that works, how the specification language works, see these examples, and start playing with them.
Yeah. Okay.
So that might take a little while, but we'll get there.
Okay. Michael, time for you to go to the real work, I think.
Yes, it is. Yes, indeed.
Thank you very much.
All right.
See
Thank you, Jan.
next week.
Yes, indeed. See you then.
Okay. Bye-bye.
Bye.